Not sure that the board shows up at all well for the camera.
It does, it's the angularity that sometimes is the issue. Like it doesn't get the whole whiteboard.
But what I'll do is I'll read out the problem numbers. So the test 3 is from chapter 8, exercise F, section 4, which begins on page 436 and includes problems 18, 20, 22, 24, 28, 32, 34, and 38. So it goes to page 439.
So we do.
But if you like, before we get started on it, we can go over some. We haven't actually covered the replacement rules. Hello, Sophie. Here's the test. We're not starting it yet, but I posted that.
Okay.
And actually, you can start it whenever you like. You can even do it whenever you like, as long as I get it before the end of next week or so, right?
I have to leave a little bit early today. I will email it to you if that works.
That'll be fine. But I was going to cover the second section of replacement rules. So we hadn't done that yet. There are 5 additional replacement rules. This is page 428. And includes transposition. So if I have, if P then Q, that's equivalent to if not the case Q, then not the case P. As you can see, and that's referred to as transposition. So if P then Q works out to be logically equivalent to if not Q then not P.
Sorry, what page did you say this was on?
That is on page 428.
So is it called transposition because you flip the letters?
Yeah, I guess.
Okay.
Oh, it was interesting getting your responses to the question, why was hypothetical syllogism referred to as hypothetical syllogism? I especially like the one who responded by saying, probably because it's hypothetical.
Oh my gosh.
Can't disagree, you know. However, yes.
So the middle one is equals to, or
Oh,
the middle symbol, is that equals to, or?
yeah, this is if and only if, or you might think of it as logically equivalent.
Okay, okay.
In other words, this is exactly the same as this logically, even though it's transposed, actually. You know, so.
I just want to make sure.
But if you do your truth table with this, you'll find out that under the conditions that give this a true-false situation, that exactly the same conditions give exactly the same truth conditions for this, so that this and this are logically equivalent, so that the one is perfectly the same as the other.
Well, that does make sense.
So wherever there's a situation where you have the one, you can replace that validly by just putting the other there. Yes.
So would it not be right? 'Cause I was trying to make sure I wasn't asking a stupid question. So you know how it reads, if P then Q equals not, if not the case Q, then not the case P. If the P and the Q were reversed, would that be logically incorrect? Because it would read P, Q, P, Q?
The thing to remember is what all of these argument forms and replacement rules are talking about is the shape of the argument, so to speak, right? So I could have all kinds of things replacing P and all kinds of things replacing Q. They're variables for even compound statements.
Okay.
But if I have a major, the main logical operator on the whole statement is a conditional statement that says, if the left, then the right.
Okay.
That is logically equivalent to saying, if not the right, then not the left. From here, right?
Not the- Okay.
So, and vice versa. So that if you have not, if not this, then not that, that can be transposed to be if this, then that. I'm obviously not saying this and that in the sense of the same thing, but what comes first over here? So, and by the way, on this page, they give you some valid examples,
What
right?
page?
This is page 428. Yeah, all these are listed on that card in the back of the book, but they're also introduced in this particular section here, right? And so transposition is given valid examples here. The first one says, if S, then not Q. And then, wait a minute. What are they doing here? Okay, so this is an actual argument then. And so they're saying, okay, premise 1, if S, then not Q. Premise 2, if P, then Q. Therefore, if S, then not P, right? Step 3 they give in the proof is, if not Q, then not P. And you're wondering, okay, where did that come from? Well, it came from line 2, if P, then Q, transposition, right? In other words, they just use the rule, transposition, to change the second premise.
But they're equivalent, so it's not
What
like
they're
it's
equivalent.
like
So
saying that, basically.
it's just referring to the rule, knowing that what you've done is just changed it in appearance only, not in its logical nature, right? And then the next step is if S, then not the case P. And how did they get that? That's hypothetical syllogism from lines 1 and 3. And that's the conclusion you were trying to get. So, so this is a valid use of transposition in a proof. And a second version of it they have over to the right, where premise 1 says S and not M. Premise 2 says if P or R, then M. So therefore, as a conclusion, not the case P and not the case R. So can we check this and see if it's valid? Well, number 3, let's go step 3 and use transposition on line 2, which notice this is a little bit more complex, but it is a conditional statement. So you take what's on the right from the original, M, right? You negate M and put it on the left, and then you have a conditional, and then you have a negation sign in front of what was on the left in the original, which is the parentheses P or R. Right? Should I write this one up so everyone can see it?
You want yourself to be video captured?
I don't think it'll help, but you can do it if you like. I just didn't want to impose on everyone. But so S and not N. Premise 2. If P or R, then N. And the conclusion is not the case P and not the case R. The suggested steps to prove this. Step 3, using transposition on this one, line 2, right? We get not the case M, right, this, not the case M, then not the case everything that's on the left, P or R. We got that from line 2, trans. For simplification from line 1, and they get not M. Step 5, we get this, because this is modus ponens. If this, then this, but I do have this, so I do have this, not the case P or R, and that's modus ponens from 3 and 4. And then step 6 gives me the conclusion, which is not the case P and not the case R, and that comes from line 5 using the replacement rule De Morgan's, or DM. Sorry, I got my M. Some books, De Morgan's is abbreviated D, small e, capital M, so I have it. So that's a valid application of the rule transposition in both of these cases. But they do also give you an example of a misapplication where you might accidentally misuse the rule. And that's when you look at if not the case P, then not the case Q. Notice what they just did is they deleted the negation signs, but left the variables where they were. So you end up with if P, then Q. Remember, that's not going to work. It would have been right if you had ended up with if Q, then P. That would have been fine. See how that works? Transposition, you have to transpose the sides. And in doing it, you're adding or losing negation signs. And if you think about it, if I had not the case P, then Q, and then I made this transposed, I would have not the case Q, then not the case P. And double negation gets rid of the two negations, so I would have ended up with P.
Could you say that one more time?
Yeah. say I had not the case, if not the case P, then Q, right? This, since there's no negation here, I add one here, I've transposed them, right? But now what's on this side has to have a negation sign, but there is one already on this, so that means I've got negation, negation. And rather than leave it like that, keep in mind that they negate, they erase one another when you have two, right? And so you can have, so from this properly applying transposition to it, I end up with this. So you see what's happening is the shape of the argument